Hello everyone, today we are going to learn parametric points on the ellipse and tangent equation to the ellipse and also position of a point relative to the ellipse. If we connect any point on an ellipse to both the focus, then sum of the distances of that point from both the focus will be constant and equal to the longest diameter of the ellipse. And regarding the position, the condition of a point being outside like U and point being inside like W will be as displayed. Okay, so this is the problem of an ellipse which we are going to discuss about in a while. Okay, so we will just be using the standard equation of an ellipse with the center at 0 to find the length of semi-major axis A and semi-minor axis B. Statement says that there is a point S PQ in the first quadrant and there are two tangents which are drawn from this point S to the ellipse, and one tangent meets at one endpoint of the minor axis and the other touches ellipse at a point T which is in fourth quadrant. R is vertex with the positive x coordinate, and it is also given that the triangle ORT, O is center, ORT has area which is equal to 3 by 2, and we have to find P and Q. We have a conclusion that one of the tangent which meets ellipse at one endpoint of the minor axis will be y equal to 2. And if we find out the equation of other tangent line ST, then we can find coordinate of point S. Here is a graph showing parametric representation of a point on an ellipse which is derived from the auxiliary circle. And now let's get back to our problem. And we need to find out the line equation of ST, but we first need to find out point T. So we take point T as a parametric point, that is 3 cos theta 2 sin theta, and also our point theta is in fourth quadrant because theta is taken as a counterclockwise direction. Now we are going to use area of triangle ORT to find out the height of triangle ORT, which will provide us y coordinate of point T. But be careful in area calculation. In area, height is taken positive, which is magnitude of y coordinate of point T. So now we have mod of sine theta, which is equals to 1 by 2, and our theta is in fourth quadrant and sine theta is negative in fourth quadrant, so we take sine theta equals to minus 1 by 2. Before moving on, let's see what is standard equation of a tangent to the ellipse, and then we will calculate equation of tangent line ST. A tangent line equation at point P having coordinate UV looks like this, and if we take point P as a parametric point, then the equation of tangent line becomes x cos theta by A plus y sin theta by B equals to 1. Okay, so now we calculate tangent line equation by putting values of sin theta and cos theta in a standard equation. We have sin theta, and if we use identity sin square theta plus cos square theta equals to 1, then we get value of cos theta. Take the value of cos theta as positive because cos theta is positive in fourth quadrant. For more clarification, here is a plot of sin x and cos x together, which shows that sin x is less than 0 and cos x is greater than 0 in fourth quadrant, that is 3 pi by 2 to 2 pi. So now we have the equation of tangent line, and now we are going to solve for the point S, and we have the value q which came from y equal to 2 tangent line, and we have to find out the value of p. Just putting the value of q in tangent line, we will get point p. So we did the calculation and we found out that the coordinates of point S are 3 root 3 comma 2. So we have option A here, which says that q equal to 2 and p equals to 3 root 3, which we found. So this option is going to be right answer. Thank you.